what I'd like to do is give you kind of a look under the hood of the process of what the survey is going to go through for when you get, quote, that job in the field. And I'll kind of start, and it's going to be a high-level overview. Certainly ask me if there's any questions or something. I'll be glad to kind of do a deep dive on any of these things you have question with. In a perfect situation, some type of localization or information from the surveyor is going to start out with their localization or information that they've derived that they send to you. This is an occupation sheet for an opus point. What this does is the surveyor will go out and cook on this point. I think this was a couple hours, started at 7 o'clock, ended at 9:24, and this is a spot that they got and put together and built to bring a GPS point to this point that they found in the field somewhere. So here's the map and information, so people like us can find it on the internet and then go to the field and locate that point. Here's the second sheet that has a description of what they use to derive that solution and how good the point is and so forth. And a couple things I want you to notice here. If we look down at the bottom here, we have UTM, Universal Transverse Mercator points. We're in Zone 12. This is Arizona. And then the state plane coordinates in this one is Arizona Central 202. This is a job near Tucson that we went and did an aerial topo on. So we're working with the surveyor, and they're doing their thing, we're doing ours. I'm going to show you how they kind of combine later. And we've got a decent scale factor. The easy thing to remember here is when you have a scale factor, you want a 1 and then the decimal point and then 4 zeros, or in this situation, you've got a decimal point and you'd like 3 nines before that. This is 3 nines and an 87. That's going to be okay. I'm not going to worry about it. Sometimes they'll get out of line and that'll make some real problems. Another thing, I want you to notice the elevation height and the ortho height. This is what's referred to as the height from the ellipsoid or the geoid model that is used to simulate the Earth, because it's not a perfect ellipse, but science put that in so the GPS height is different than local elevation. That's something that may confuse a lot, but it always has to be respected. So that's brought in, and let's just take a quick look at a couple reports here. This is control points. This is a TopCon project. So this is a localization from TopCon. You see I've got 3 zeros and a 1 after the scale factor, and I've got a small inclined plane. This is another thing that the GPS will do. It basically takes your job and sort of flattens it out, because things can get complicated in the GPS world. And we've taken these coordinates and matched them to these lats and longs, and you see that the data we're using is WGS 84. So this is good enough to get started. This was occupying what the surveyor had already done, so we feel good about that. These people can get to work. The last one I want to look at is one that was done in Trimble. This is from a data collector, and this is for the job that's underlying here on the screen. So I'm going to look at some information here. You'll see that the units are feet. This is an international feet. This is a job in Arizona. And this is information taken. You'll see that we have a grid position. Here's this point 121. And then the GPS shot is 121 3D. So we can start and look at the lats and longs, the state plane coordinates, elevations, the WGS height, You see we're 1155 to 1253. That's pretty common, right around 90 to 120 feet in this part of Arizona. You'll see that difference, so it's something we try to pay attention to. So this allows me to see kind of the raw data collector information, and with that in hand, it now turns into the localization for this pretty large highway project that we worked on. And with that, I see that it's calibrated. I can click on this and find that same summary information that I derived from the DC file. And if I look and I click on the site calibration button, it would bring me over here to the calibration settings, and I can see exactly what points got used and in which dimension. This is a vertical only, so I've got obviously a good height on this, but we didn't like the locale of the point, or when we initially applied the solution, that didn't work and didn't make a lot of good sense. So with this job, once the control's been established, that got released to everybody, so we literally were all on the same page. It makes the job go better and easier, and it's always my recommendation that you have that control from the surveyor directly to you and use the points in the manner in which they did, and you'll arrive at the same solution that'll give you some information that you'll be able to use confidently, but also help answer questions if there is a discrepancy.